Hey guys, this is your civil bro Mainak, and today we will design a building that is an industrial building of a milk factory in STAAD RCDC, and also we're using some parts of AutoCAD also. So I'll show you the details about the whole project, and I have my course on Udemy, and in that course all the materials and the detailed things are available. If you want to avail that, you can click the link, check the link in the description. So the first thing which we want to do while you get a project is that we want to study the first floor plan, second floor plan. As you can see, this is an extension project, so we already have this area which is already constructed, and the area in which you have see the grids, these are the extended areas. So we have some processing units, and in the first floor also we have some there will be some machinery and some storage, and we have a lift and MD's room. So light machinery will be used. So first thing, when you get a project, to decide what are the things which you need to know. The floor to floor height was given by the architect as 4.5 meter, and as we see, we need to see from the soil test report. So here in the soil test report, we have this 3 depths as which has been given. So 22.4 will go with 2 meter depth. Okay, so 22.4 ton. So if we calculate this into 22.4 into 9.81, it comes as 219.744. So it is a pretty stable soil. I'll say 219.744. It's good SBC. So we'll take this SBC as 21. Let's take this 219, okay, or you can even take 220 kilonewton per meter square. So this is the LPC which has been taken, and the depth, that foundation depth will be given at 2 meters. Okay, and plinth height is also required. Okay, plinth height will take at let's say 0.4 meter. Okay, so we'll take this and do consideration. So total foundation depth will be 2.4 here. So these things will be done. So then we get the plan, and we just get this and delete all the things which are not necessary. So this is the first floor plan, and this is the ground floor plan. Then we place the columns. Okay, so once we place the columns, then we check by overlapping. So this, like this, we check by overlapping. You can suppose this is the thing, move it, okay, at the common point, and then we move it here. So this is a very detailed process here. Okay, so this is actually the first floor, the marked blue one, and the remaining portion is the ground floor. So as you can see, so I have told the architect to just adjust this first floor, this the dimension in this line. Remaining is good, and then we actually check the overlapping, where if all the beams and columns will be in the correct directional one or not, if any column is obstructing any passage. Okay, so like this we check, we need to check this. So this is a very long process, that's why I didn't make the video. So let's go, but with experience you should be able to do that. Okay, so, and I'll just move this now to here. Okay, so okay, Ctrl Z, yeah, it's good. Okay, so this is how we check or place the columns, and then you overlap. So we have total 60 number of columns which has been given here. Then you find out the coordinate for this design in STAAD Pro. Okay, so 60 number of columns, as you can see, these are here, and then we write the coordinates in Excel, so that we can easily import them, and only 2 intersections are there where we don't have columns, so it will be pretty much easy for us, and remaining all portions will have columns. So these are only the 2 portions. Okay, so we have to remember that. Then we open the STAAD Pro. So STAAD Pro is open. We'll click on new and model, and then we'll just give the location of the file. So name and location has been given, and then just click on create, and this thing will be created. And then you don't need to do anything here, just to go to the Excel. Okay, and in the Excel file, just copy this along with the serial number. We will copy this thing 62. Okay, 60 are columns here. So Ctrl+C, and then we come upon here, click here, and then Ctrl+V, click on OK. So this is done, and we go to the view. This view will be comfortable for us for joining. So only these two things don't have columns, so remaining things have. Okay, so go to geometry and use the add beam option, and we'll add the beams here. This is we'll use this, by the way, as our plinth level. Okay, and we'll also do the foundation level also in quite a bit time. So we'll join this like this. I'm just skipping this part of like this. We can easily join this and we'll move forward. So now this is complete. So for all the secondary beams which where its moment will be 0, we have to do the moment as equals to 0. So suppose this is a beam, these beams and this beam and all these beams, and we have to figure out which is the start and which is the end. So when we go here, the bottom one is the start and top one is the end if you connect it from top to bottom. And if you go from left to right, the left one is the start and the right one is the end. So this is the general convention. Or else you can just to be confirmed, just right click on any portion and go to levels, and here you have the beam color, start color and end color. Just apply it for now. So you can see the start and end colors here. So this is the start color, this is the end color. So like this you can understand this. So in this particular beam, this one, there is no column in the end, so we have to do that. So we just right click, or just simply we can double click here and go to change releases at end. Okay, and releases at end we don't have any moment here, and click on, you can click on add if you want, or you can click on assign also. Okay, so assign, close it. So like this, just this one and this one also double click, change releases at end, assign, close this one, right click, properties. So pin connection has no moment, that's what we are doing here. And then this beam also, which is the last one, increase at the end. Okay, double click this, and then end. So this is done. And for this also, these small beams also, these two portions, you don't have any column here. So in this one, it will be at the start, both of them. As you can see, you zoom in, little bit zoom in, you can see green is at the bottom. So this is the start. So at the start, the moment will be released. Okay, right click, or simply just double click this, and here release it at start. So no columns here, so assign. And here also, this one also, double click, 92. Now at start, no moment. Okay, simply close this. So all the secondary beams should be done like this. Now we can go back and to the default view, right click, go to levels, and just apply, because we don't want that. So our plinth level is completed, and you can see all the connections where you have the pin connections. It is showing here. And now we need for the here columns at the foundation level. So denote the connection between the foundation and the columns. So for that, we'll copy the coordinates of the columns here. Go to the Excel file. Here we've already done that. So 2.4 meter, 2 meter is the foundation depth, 0.4 is the plinth height. Okay, this way I have taken. And for this, just copy this. They start from 67. Okay, so we'll copy this, and I'll check in the STAAD Pro. So it starts from 67, is okay. And go click on paste, and we can paste it here. Okay, click on OK. This is pasted. Now we go to our 3D view. Okay, go to view, go to click here and on isometric view. Now we have to like add beam and join all this, right? So since we all portion doesn't have columns, so we have to do it like this. So let me do it. Okay, so once this is done, this thing has been done here. So this is the plinth level and this is the foundation level. So what next thing we can do is go to view, we can go to the front view, and we can go to select and the node cursor, and we can select all the nodes. Okay, there are two ways of doing this. Select on these nodes, then the node tools will appear, and then assign supports, and then we'll create fixed supports, and select the support, and then select the nodes once again, and then click on assign, and yes, so the fixed support will now be assigned. You can see here in the view, in the 3D view now, the fixed support has been assigned. So just click it, this selection will occur. Now this is done. So now we'll use translation repeat for you can use translation repeat, or you can use the Excel once again. So I will use translation repeat. So go to geometry, or go to select, and go to node cursor. So all the points which are secondary, they will not go upwards, obviously. They will not have columns, and all the points which have the columns, they will be connected. So we cannot use link steps because all the steps will not be linked. So we have to use Excel and coordinates, and then join all the portions where we'll have the link steps or the columns. So we'll go to the view, and we'll go to the front view, and we'll just select this floor or the plinth level, excluding the columns. We'll try to do that. You'll see in the 3D view as well, and we'll use the translation repeat, geometry, and we'll use that option of translation repeat. We cannot use link step here because all the connection don't have column. I'm telling this again and again because many people ask me in the comments. So if you design a practical building, you'll see these conditions. So 4.5 meters is the height. Link steps can't be used in the y direction, obviously. Click here again, and then click on OK. Then we have to add the beams here one by one. It's pretty much easy. So let me do that like this. Okay, you can deselect this and then add, then it will be easier for you. Okay, or another trick for getting it easier, just you can go to view, you can go to the front view, and this is the, you can select the supports here, right? Go and have the support selected. Just go to select and the beam cursor, and select the supports like this, and then you can go to view and go to 3D view. Now it will be easier for you to join. Okay, now let's join this. So all the columns have been added. You can check whether everything is okay by clicking parallel to Y. Okay, and then now all the columns have been added. So once you add this floor, so this is the plinth level, this is the ground floor slab, then the next floor is easy. Okay, so simply you can use the translation repeat option. Go to front view and just select this along with the you can select it along with the columns, and then use the option of translation repeat, geometry, go translation repeat, y direction, 4.5 meter, and here we go and click on OK here. So now the next step, as you can see, this was easier. Now we have to insert the slabs, so that is also an important step. So for that, let's just focus on a particular level. Let's focus on this level, for example, and right click, and we have display a new view. Just click on OK, and it will be done. And since we did by coordinates, so this view is the most suited for us. So then we'll go to geometry, and you have this add plate. So just simply click on add plate, and we have to add plate like this: 1, 2, 3 and 4. So we can do all this together or individually, but you have to avoid the portions where you have the staircase. So I'll just press Ctrl+C. Okay, this portion I have staircase here. I'll just show you the floor plan. So I have a staircase in here, in this portion and in this portion. So in these two portions there will be no slab, so I'll avoid the slab in these two portions, and we'll do it here like this in all the remaining portions. So let me do it. You can also just, since you are not designing slab, you can also just take a whole slab, but it is advisable that you do it one by one. So let me do it. So once this is done, you can go to view and click on 3D rendering view to check. So this is the lift portion, this is the two, these are the two staircases. So we have done this accurately. So what you do, you just go to view and go to this isometric view, and go and view, right click. There is the option of display whole structure here. Okay, so then make sure you go to select and select the plate cursor. Plate cursor is selected. So when the plate cursor is selected, you can just select Ctrl+A, or simply click on simply we have to select the plate side. So so if this is not working, just again double click here, and then I think you will be able to do that, and select all the plates which are there. Okay, So like this, all the plates will be selected here. So we need to use the option of go to geometry, go to translation repeat, go to y direction and click on 4.5 meter and click on here in y direction. We'll just copy this. Okay, click on OK. So now this has been copied here. Let's go to view and go to 3D rendering view and see. Okay, so you can rotate this, left click on your mouse and rotate this. So now this has been done, like the slabs have been provided. Okay, so this step has been completed. So now let's go to the geometry is complete. Let's go to properties and just edit the properties. First of all, we'll go to thickness and define the slab thickness. Minimum 150 mm thickness will be there, or 175 or 200 can also be there. Let's take 150 for now and click on add and then close this. And then we'll go to define and rectangular section and the columns. Let's go 450 to 450. Industrial building in seismic zone 2. Okay, then click on add. And then for the plinth beam, let's go here. ZT is the starting one, so let's go 250 into 350. I think that will be not be sufficient, but okay, let's go with 8 first and we'll see remaining later. So this is done and click on add here, and the last one is for the roof beam. For the roof beam, I'll go for the initial size of 300 into 450, so 0.45. This just click on add. So these are done. So for plate, go to assign to view and click on assign, and this will be assigned for the plate. Rectangular, this is for the columns. You can go to select and parallel to Y and then assign this. And then for the plinth beam, you can go to the view and go to the front view, and here we can select the plinth beam, let's say for now, and can assign to selected beams, assigned and yes. And for the roof beams, you can just select this and press Ctrl and then select this and then assign to selected beams, assigned and yes. So once this is done, now the properties have been completed. Now you see the material complete already assigned. Okay, so no need to worry about that. Concrete, you can edit this. These are the properties here. Consistent, this is okay, M25 concrete. So now you go to specifications. So the specifications already we have given, start and moments. Now we support also we have given. Now we come to loading. So then we define the loading here. So this is a seismic zone 2 loading. So no, not for seismic loading will be there, but still will assign. We have to assign it to seismic load just to be safe. So take the latest seismic code here and then click on generate. And then we have the zone. This is in the zone 2, and we have will not consider ductile detailing here. So if you consider ductile detailing, then it will be this. If you don't consider ductile detailing, then it will be this. So not consider ductile detailing for this particular building. Okay, so this will come under important buildings, since it is an industrial building. It's an important building, so not in all other buildings. It will come as an important building. And the soil will be this is actually a very hard soil, but I'll still go with medium just to be extra safe. And then click on generate, and then click on generate here. Okay, so I should have clicked on add, sorry. Okay, so have to do it again, sorry for that. Reinforcement, the RC building ordinary moment resisting frame, important building, medium soil, and click on damping ratio 5%, and foundation depth, yeah, this one it needs to be changed. Foundation depth is 2 meters. Okay. And the time period also we can change here. It is better we need to define it. So if you consider the building this 5.7 in the x direction, and the other direction it is 18.225. okay, so here this is the x and this is the z here. So obviously in the z direction the distance is 18.225. so let's see the code. Where is the code? Yeah, there is the code. Let's see the code for a building of height is 9 meter, since 4.5 meter. Okay, So TA in the the Z for a building, I'll just do this. Now in the X direction is equals to, and Z direction is equals to. Okay, so it's pretty simple, X and Z, and we see from the STAAD that X is the this, you can say, horizontal direction. So along the horizontal direction, the distance is, you can take as, let's take at 5.7. okay, you can write here in the Word file is the 5.7 meter. Okay, and the other direction is see the other direction here. It is actually 56.51. okay, so you can take 56.6. so next we can take 56.6, and on that we can take 18.3, and we'll do the calculation here. This is 0.09 into 9, the building height, so this will be fixed, and this value will change. Okay, so if we calculate this TA, let's calculate TA in the X direction first. Okay, and then this will be in the Y direction also. So TA, sorry, Z direction here, Z, we'll calculate this, and let's see the value. We got these two values after the calculation, 0.11 in the X and 0.19 in the Z direction. So we'll just put it here. So you can see if you don't, then it takes any approximate values. If you do it, then it is accurate as per the Indian code, 0.11 and 0.19. so just do 0.11 and 0.19. so this is done, and click on generate, click on add. So this is add now. Okay, this is add. The remaining things we will add later by using the STAAD editor. Okay, so primary load, first of all you will have to add seismic SLX. okay, seismic load X, and then you can add the seismic load SL minus X. You can add then SLZ, you can add, and SL minus Z you can add. Then dead load DL, add this. Then live load LL, add this. Okay, click on add, and here go to seismic loads, extraction, and a factor of 1. Right, click on add. Then in the minus X, click on add here. This seismic loads here, go to seismic loads, extraction, factor of -1. Click on add. Then Z, add. Sorry, what happened? So, Z, click on add. Seismic load, Z direction, factor 1. Click on add. Now close, add seismic load, Z direction, factor -1. Click on add, close. Dead load, we add some dead load here. Click on add. Dead load will be added self weight, obviously, and then the member load. So for 4.5 meter, if you calculate here by 20 into 4.5, the walls are of different sizes, but mostly 0.23 into 0.23. Sorry, so it will be 0.23 instead of 23, so it is 20.7 the load is coming. So let me see the wall. So the walls are of 0.23 thickness here, so we have to provide 20.7 is the load. So there will be some plaster also, so let's go 20. Okay, so wall load will be more here, obviously 20, and then click on add, and then close. Okay, so did a mistake, it will be -20 instead, not 20, because this is the gravity direction, so to change that. Okay, so and then the floor finish loads, so we'll add the floor finish load, and this will be an area load will apply, or can apply the floor loads, that's better. So it's minus 0.5 will assign the floor finish loads, and the Y range will start from 4.4 to maximum it is 10, that's it. Okay, and click on add. The floor finish load will be added here. The live load will also be added, and live load is 5 which we are adding. So floor loads, and floor load of minus 5 kN per meter square, and the range is same 4.4 to let's say 10, and click on add and close. So edit this, yeah, this is okay. Minus sign, I'm just taking minus sign, I'm given or not. Okay. Minus 5, it's okay. So now self weight you can just assign to, you better go to view and click on this view, and then we go and assign to view, click on assign and click on yes, self weight has been assigned. Now the floor loads, here I have to also to assign parapet wall load, but we will do it later. Okay, so this has been selected, and we go to, let's say, the front view, and do this and do this, and we assign, right, things have been assigned here. And once the things have been assigned, you can also assign the parapet wall loads also. So go to this, select and right click and click on new view, not levels, click on new view and click on OK, and we'll add a parapet wall load here. Click on add parapet wall load, let's say will be member load -3, add, and again we can add here a load for the staircase portion. It will also be 4.5 meter, a little less I assume. So let's give 10 for the staircase and lift portions. Okay, so this will add and then close. Then we go to the view which suits us the most. So this portion 10, let's delete it first. This portion, this is 10, this portion, this is 10, and this portion, this is 10. So assign to selected beams, parapet wall, done, and this is done. And then we go Ctrl+S. Okay, save this, go to utilities, go to command file, save this again. Command file will open here, and we'll see here, and from here we'll go here, and we'll see this is the loading type. From this dead load we'll copy this self weight, member load, floor load, these things will copy. Okay, Ctrl+C, and then we will go here in this portion. Okay, and click on enter, click on paste. So Y and -1, remove member load. Instead of member load we'll write weight WEIGST, because it's seismic mass source. Okay, this is also WEIGST, seismic mass source, and then it is no direction here, GY 0.5, member load, this will be weight WEIGST weight, and this will also doesn't have any sign, this also doesn't have any sign, right? So no sign for this, no sign for this, and then we get a portion of the live load in the seismic mass source, that is point. If it is more than 3, okay, so if it is more than 3, how much, what is the percentage? More than 3 it is 50%, so 50% of 5 is 2.5, right? So 2.5 will take. So just go to the editor and in here in the live load, there is a live load. This is the live load, flow load, this 5, right? So we'll copy this flow load 5, Ctrl+C, and let's come here to the seismic mass definition here, self weight, unit member weight, then enter, paste it here. This will do weight, GST, GY, get rid of it, and it will be 2.5, Ctrl+S, and then close this. So if there is any error, it will show. So likely there is no error. So the modeling part is complete. You can see here, go to view, go to 3D rendering view, and you can see the zoom in and see the model from here like this, right? So now we'll go ahead and just create a load combination. So find the auto load combinations here, and here you can go as per 56, generate loads. Okay, you can see these are the load combination. Click on add and close this. So you can see this is dead load plus seismic load, 1.5 times seismic load, and 1.2 dead load plus 1.5 seismic load plus minus. So all these combinations are there, so it's perfectly fine. Then we go to analysis. So in the analysis, we'll go to concrete, and after going to concrete, we should just select the code as 456, and then just create on select parameters, and we'll select the parameters from here. Only the things which you need mostly. We'll do this. Let's take this. Let's take secondary. 1, 2, 3, 4, 5, 6, 7, 8. Commands, design beam, design column, take off, close it. Define parameters. For column 40 mm, for beam let's take 30 mm, and complete, let's take with M25. 550 also. Maximum main, let's go with 25. Maximum secondary 10. Minimum main we go with 12. Minimum secondary 8. We'll close this. Design beam, select parallel to X, parallel to Z, same, parallel to Y, same as concrete, parallel to Y, same as parallel to X, parallel to Z, same as select to view. So this is done, and once this is done, we'll go to analysis, and here analysis commands, and you want or check, if you don't want it, then you can just ignore that and just click on add, close. Done and run analysis. Structure should be saved, and if there is any error, it will show the error, and the members which are failing. So there are 25 warnings, so 25 members have failed. So it was expected. So we will just see. So let's see the beams, the concrete design. So here we will do the concrete design properly. So if you want to know actually the number of bars which have STAAD Pro has calculated, so you can easily do that using the AST here. So for example, here there is 4 bar of 32 mm the top maximum, and 4 bar 6 bar of 20 mm the top. So the top reinforcement AST is 4 bars of 32 mm. So 4 into, so it will be 4 into this is the required AST here. So if you want to substitute by 32 mm, so it will be this by, so 25 mm, it will be this divided by 25 for example. So it will be 6 point something. So we cannot give 6 point something. We can give 8, okay, or we can give 4 and 2 or something else like this. You can give to give it in even numbers because of the arrangement. So if we give here let's say 4 into let's say 25 plus 2 4 into 20, then it will be little bit difference, but it is almost sufficient here. So like this we have to decide on this sizes here. But the thing is, for this particular size, this size is coming. Let's see the concrete design here again. Okay, so 11 bars of 16 mm, 12 bars of 16 mm. So this is, I think, pretty much okay design for a size of this done. Okay, so like this, for 24 bars of 24, this is perfectly okay. 9 bars of 10 mm in the bottom. This is perfectly okay. Now you have to identify the things which are failing, right? So for designing big projects like this, once you do the analysis and designing STAAD Pro, it would be really good if we had an option to check which members are failing. But we have a option here where property name members failed, but this only works for steel and aluminum design. But we are designing RCDC, so it doesn't work. So this is a property which the developers can look into. Unfortunately, this is not the case. That's why we have to use RCDC. That's why for complete projects, since I do complete projects, you can refer to RCDC, which saves us from this. So first of all, you save the file, and after saving the file, click on yes, and after saving the file, you just open the RCDC. And if you have directly access to advanced concrete design, then just click on this RCDC, advanced concrete design. First step which we'll do, we will design the columns here. Okay, so just click on accept. So firstly we're going to design the columns here. So project data we need to insert here. So first we need to design the beam column. So columns will be first. So create new project. You can see this is imported. First only you save the file. Okay, so then we can also after saving the file, you can go to settings, design settings. We will not use ductile design here. Okay, and then IS 456 is already selected in here, so just click on OK, and reinforcement settings will keep all of this by default. So we cannot change the that is FE and M25, these things we cannot change here. So this is an unfortunate thing, but in footing and other beam we can change, so there is no problem with that. So seismic load in Z direction, we will define that. Sorry. So yes, I will define, and two load cases, just click this, primary load cases. I can input load combinations from there. Okay, we can easily do that, or you can create a own load combinations as well. So you can import that from the STAAD file, or you can just click on OK and add for template for regular structures. It will import all the load combinations which you are seeing here. So this is the same, so you don't have to do anything, just click on OK. So load combinations are imported. Now you simply designs, and let's see the design results here. So you can see the columns which are filling here. Firstly, we have to change the reinforcement and the M25, which is great. So let me show one how to change it. So this is failing. Firstly, this is okay. I am okay with that. And just do this at 550. Great here. And cover also I can change here 40, but this doesn't make much difference. Not make any difference in the design. Okay. So and then the design. So still it is failing, so I have to increase the size. So here I'll just unlock this and change the size to 500, and I'll just Ctrl the C and let's say Ctrl select there on Ctrl V and then redesign. So now it is passing, and the rebars also 16 rebars should be there, and it is okay. 432 and 1225. But if you don't want to use, like I don't want to use 32 mm bars, if 16 mm bars are there, 32 mm bars I don't want to use, I want to go for maximum of 25 mm bars. So I need to increase the size here. Okay, so I'll increase the size to, let's say 550, and okay. So why I'm doing this, I'm just select this and paste it here, right, and then redesign, and now it is okay for me. 425 and 1220, this is perfect design for me, and I'll accept this. And this is a C1. If you want to see which one is C1, just go to design input, and you see this is C1. This is the first column which you're designing. Like this, we have to make all the columns safe. So this is a complicated, not complicated, this is a very time taking step. We unfortunately you have to do it. I'll do it, and then we'll see the results. So once we have completed the column design, as you can see, these are the column design. Sizes 550 maximum, 450 minimum. This design is completed. We save the design output. We go to reports and we take the text schedule, non-tactile, which means non-tactile design. So we take the text schedule, we save the text schedule, and also we take in the design input also the final column layout also we save it, and then we go to file and then click on footing design. So then the footing will be designed. Okay, so we can close this now. Make sure to save it. Okay, so that it stays. So footing design, this has been done. So we don't have to import this, because since we had clicked from that, so already the column data has been imported here. So the settings we need to do here, general settings here, M25, FE550. So this needs to be done. So we check the dimension here. So this is the dimension settings here. Net SBC, this will be our 220 kilonewton per meter square as per our soil test report. Okay, and then foundation depth will be 2 meters. Okay, and then these things you need to check here, and then click on OK. So then this is done. Go to settings, go to basic load cases. This, since you have done from the column, this already is done, so no need to do anything with that. Okay, so then you need to do one thing. Okay, so this is done, and we'll just do this. And for sizing also, for deciding the size of the footing, this needs to be done on factor load combinations. So now the footings will be designed. So let's see if there is any overlap. So yes, there will be some overlaps here. The places where we have overlaps will give the your footing as combined footing. So there is very few places, because these two were passages. So here most of this, or in fact all of them will be combined here in this area also. So So we'll combine this footing in the drawing here. Okay, so now we save the file for the footing design here like this. So it will be our footing layout, and let's see the reinforcement here, and the sizes are okay, and the reinforcement here you can see 10 mm bars. So reinforcement is also okay. And to save the schedule, text schedule, vertical, horizontal doesn't matter actually. Let's go horizontal. Okay, no, we'll go vertical. It's easier to read actually. Okay, so save not save the project, file, save as. So it will be footing design. Save this. Then we can save this file, footing schedule. So this is saved. Now footing and column are done. Next we go to beam. First we will go to plain beam. Okay. So for the beam we will go to file. Okay, and we can click on new, and we save the project info. So after saving the project info, you need to do the STAAD file, and then we go for the beam. So various levels, we go for the plain beam first, right, and create new project. So since this is a large file, so the first thing which we'll do is save the file, because sometimes the RCDC crashes, so don't want that. Okay, so go to file and we'll go to save as, and this will be RCDC files, column design. This will be PP for clean beam, PP design, and save this file. So once this is saved, we go to settings, general and reinforcement settings, and then ductile design node 2 will just to FA550 here, and FA550 minimum rebars, maximum rebars, this is okay. Click on OK here, and go to settings and go to basic load cases. Here we will just do the load cases here, earthquake X, and earthquake Z, and dead load, and then the live load, and then select them, do this, and then click on OK. And then obviously the sizes which I have given will not be sufficient, I guess. You have to increase the size to 250, minimum 500 depth you have to go. Let's see what are the results which we get. So we can see this beam looks failed. So let's see. So bottom left, you have this bottom mid. So maximum is this one, I think, 232. So these are okay, and these portions failed actually. 32 cannot give, but you can calculate the AST and all. This is okay, I think. This percentage is okay, 25 and 32 maximum is okay, because at the mid thing maximum force is there. So this is okay. So any of the beams which is failing, suppose this group is failing, right click on design, and then we can change the size here. So we go 250, we go 300, here also 300 into 400, 450 I think we can also go. Let's see. Here redesign, so it's okay, so we'll accept the design. So like this we have to accept all the designs for the beam. So all these things are passing now we can save the results. So first of all, save the file once again, Ctrl+S. Okay, after saving, go to reports and reports text schedule, and text schedule type 1 is okay. So then just click on OK, and the schedule will be saved, right? this is schedule. Now save this. So this will be our beam schedule. Save, and then we also need to save the beam layout. Okay, so for saving the beam layout, go to input and save this as the PB plain beam layout. I should have named that PB plain beam schedule. I'll change the name later. PB layout. Save this, right? So then we go for the roof beam design. So 4.5 meters, and click on create new project. So once this opens, you first of all save the file, and this file will be saved as PB design, roof beam design. Since this is G+1, so then another code will be Terrace beam design, right? So general reinforcement, and this will be 550. Click on OK. Then basic load cases, just define the load cases here. So one beam group failed, and remaining are passing. So it's into 450, all are passing here, so no problem in that. I think the reinforcement is also okay, right? We can provide that, so no problem in that. Okay. And then we'll just do design of this. I wonder which beam is this actually. Okay, this is the middle span, that's why it is failing. Okay, no problem with that. So we'll just do the size here. What should we do? Let's type 500, and if not, then we'll go with the higher size. Here I cannot paste Ctrl plus C, Ctrl plus V. No, I have to write it. In some versions you can paste, so check that out. Let's see the design. I reset by mistake, so again I have to do. Let me do it. So do it again, and let's check. I think some members will fail. Here some members are failing here. So okay. I can go 550, and then if it doesn't pass, then we'll increase the depth breadth actually. We can go 350. I think we can go 350. 350. Let's check. Yeah, now 350 is okay. I think we need to increase this. 600. Should be okay. This is pretty much okay here, and then we'll accept this design. So once this design is done, we save the file once again, Ctrl plus S. So So after that we click on reports, text schedule, and click on OK. This is our schedule. This will be our RB schedule, and then we'll have to layout here. So this will be our RB layout. And then once this is done, we save the file once again, and then we go for the terrace beam. So terrace beam, there everything will be same, but there are lesser loads in the terrace beam because only the parapet wall and all. So let's see if there is any difference. If we can go for a lower section, I think we can go. I think the section will remain the same, but the reinforcement can be changed. So let's try this out and click on new, and we'll fill up the detail. So this time we'll select 9 meter. Meter is selected. Now then we go to settings, general rebar settings, IP 550, and click on OK, and then go to basic load cases, and just do this, just do it, and then complete and load, live load, click on OK, regular structure, and then design. So one beam group failed, exactly that one which I failed earlier. You can see that design input, exactly that beam has failed. So we'll just design this, and here post size 500. Fine, this is fine. Exactly. So yeah, I think the reinforcement is lesser. Size will be the same, but reinforcement is lesser here, and we can, while grouping, we can easily, you can see reinforcement is less. So we can provide lesser reinforcement here in the grouping, but we'll keep the sizes same. We can do more economical by reducing the size, maybe 400 or something, but we'll keep the same. Just reduce the reinforcement, that will reduce the cost of the project. Okay, so then we just save this, and first of all I have to save the file, save, and this will be saved as our terrace beam design. So it's 2 floors, and I am doing this, otherwise I design by level like this. Save this project. And then we'll save the 2 things, reports, text schedule, and click on OK. Text schedule for the terrace beam. So it will be our terrace beam schedule, and in the design input will go, and this will be our terrace beam layout. And then we are done with the RCDC design. Then the remaining parts will be done in AutoCAD to present the final results.